part 2 of this practical exam. In part 2, we're going to implement the single area Ospf version 2 in both point-to-point and broadcast multi-access network. So these are the requirements. The first requirement is activate Ospf using network statement and inverse mask in routers in HAU network using the process ID 10. Okay, so let's proceed with the HAU network and let us configure the Ospf using network statement. So this is the HAU. Let us configure the by the way, before we proceed with the configuration of Ospf, this network has already been configured in part 1, the interfaces, and they are communicating only with its directly connected network. Like for instance, if I'm going to ping the interface of HAU1, because since they are directly connected network, so ping 10.0.1.14, so they are connected because their interface is directly connected. But if I'm going to ping from DCT to serial 011 of that one, 00.1, this interface, it will not connect because these are remote network from DCT network. So the network .9 or 10.0.1.8.4 and .0 is not in its routing table, so it will not it doesn't know about the network of this HAU1. So in order for this to communicate, DCT to communicate with the point-to-point network, we need to configure the protocol. In this case, we're going to use Ospf as a protocol, Ospf version 2. Okay, so the first requirement is to configure the protocol. So based on the requirements, we need to configure using the network command. So config t, we are in HAU1 router, and then router Ospf 10 using the process ID 10. Then let us issue the network. Let us configure the network 10.0.1.12, and then the wildcard mask 1, 2, 3. This is .3. The inverse of the wildcard mask is just the inverse of quad 255. And then we'll put the area. This is area 0 we use in the single area Ospf. And then another network is all the networks that is connected to the router HAU should be entered. We also have the network 0.0, the same area, and this is .3 also because that is 255 minus 252. And then we have the network 1.8, the same /30 is .3. And then we have the 1.4 network, .3 also because this is /30. Alright, so we finish entering, and then this is not part of the Ospf routing domain, so we don't need to enter the network 650. So let's save the configuration. Then let's proceed to H82. Config T, and then router Ospf 10, and then network. The network here is 10.0.0.0 to wildcard mask 0.0.0.3, then area 0, and then another network is .1.4. So they are now establishing the neighbor relationship. We have 1.4, the same area 0, and then I have 1.8, 1.4, and I have already 1.4, and then gigabit 0.0. This is network 192.168.0.7 network, and then the wildcard mask of this is 255 minus 255 minus 248, 255 minus 248, this is 7.7. So instead of .3, .7, sorry, .0 space 0.0.0.7 area 0, enter, and then end, and then let's proceed with HAU3. Okay, Cisco enable class config T, and then router Ospf 10, network 10.0.1.8, that is 0.0, wildcard mask is .3, area 0, enter, and another network is it's establishing neighbor relationship, and then we have .4, enter, and then we have another network a network 192.168 and .8.0 0.0.0 .255 area 0, and then another network is .1.0 area 0. Alright, so end, Okay, so we've done with the configuration of HAU using network command. The next requirement is activate the Ospf by configuring the interfaces of the network devices. So using interface command of the DCT network. So let's proceed with the DCT network. Config T router SPF 10. So interface serial 0/1/0 IP OSPF 10 area 0. Okay, and then another interface is the G0, establishing a relationship G0 G0/0, and then IP OSPF. Okay, and then we have DC2 class config T, and then we have interface G0/0/1 IP OSPF 10 area 0. Okay, so and then another interface, enter, and then we have DCT3 Cisco enable class config terminal router OSPF 10, and then interface G0/0/1 IP OSPF 10 area 0, and then we have another interface G0, enter. Alright, so we have already configured the OSPF, enabled the OSPF to DCT network and HAU1. The next requirement is configure the router ID on the multi-access network routers as follows. Okay, DCT2. So in a multi-access network, this one, so we need to configure the router ID. Config T router SPF 10 router dash ID 7.7.7.7. Okay, and then here is DCT2. The router ID is 666.6. Config T router dash ID 6.6, enter. should be router Ospf 10 router dash ID 6.6.6. Okay, and then we have DCT3 config T router Ospf 10 Ospf 10 router dash ID 5.5.5. Alright, so that is the third requirement. And then next requirement is configure Ospf so that routing updates are not sent into the networks where they are not required. So this is a passive. We need to configure the passive interface. Okay, so the interface that need to be passive is this one, G00, because there is no router after switch. So config T router Ospf 10 passive dash interface. This is G0/0/0. Okay, and show interface, show IP protocols. So it's already passive. And then we need to declare this G0 also as a passive interface. Config T router Ospf 10 passive dash interface G0/0/0. Okay, so right, show IP protocols. So it's already passive. And this one also must be configured passive interface. Config T router Ospf 10 passive interface, passive dash interface, passive dash interface G0/0/0. Ano? Yeah. Okay, and show IP protocols to check. So it's already passive. And this one also should be configured passive. Config T passive dash interface G0/0/0. Sorry. Router Ospf 10 passive dash interface G0/0/0, and then also /1, and show IP protocols. Okay, so 00 and 01 is passive interface already. And we need to declare also this S020 as a passive because this one is not participating in the Ospf routing domain. So enable config T router Ospf 10 passive dash interface serial 0/2/1. Okay, so and show IP protocols. Okay, passive interface 0/2/0. Right, so after that, configure the router DCT highest Ospf. DCT highest Ospf interface. This one, we should configure this as the highest Ospf interface. Config the router Ospf 10 IP Ospf priority 255, the highest priority. Oh, sorry. Router IP Ospf priority 255. Oh, no, sorry. We should define first the interface G0/0/0 IP Ospf priority 255. Okay, so and let us check show IP interface Ospf interface G0/0. I think this one. Show IP interface, show IP Ospf interface G0/0/0. Where's the command? Show IP Ospf interface. Interface this one. Show IP interface, show IP Ospf show IP Ospf router ID LSA. Okay, G/0/0. So the priority now is 255. Alright, so the next requirement is configure the router highest Ospf. Finish with this. configure the default route to ISP using the exit interface. So the default route will be, this is the config the route, config the IP route 1234 space 123. So this is the default route. The exit interface is serial 0/2/1. Alright, and then the next is automatically distribute the default route. So automatically configure the default route. Okay, so router Ospf 10 default dash information, this is the command, originate. This command is used to distribute the routing updates of all the routers, the default route to all the routers connected in single area Ospf. So that is the purpose of the default information. The default route configured here should be distributed to all the routers participating in the routing domain. Alright, and then what's another? Configure the Ospf router so that the gigabit interface cost will be 10. The cost is 10 and the fast Ethernet cost will be 100. All Ospf routers. So we need to config the router Ospf 10 auto dash cost reference dash bandwidth. This is the command, bandwidth 10,000 to make it 10. Okay, reference bandwidth, and then here also config the router Ospf 10 auto dash cost reference dash bandwidth 10,000 to make it 10. Okay, so end. Also here Cisco enable class config the router Ospf 10 auto dash cost reference dash bandwidth 10,000. Reference bandwidth is consistent across all routers, so we need to okay, and then we need to configure also here and config the router Ospf 10 auto dash cost reference bandwidth dash bandwidth 10,000. Alright, and then we have here HAU2 Cisco enable class config T router SPF 10 auto dash cost reference dash bandwidth 10,000. Oh, it's wrong. Auto cost reference bandwidth. Auto dash cost reference dash bandwidth. Wrong spelling. Okay. And then the last one is this one. Cisco enable class config T router SPF 10 auto dash cost reference dash bandwidth 10,000. Okay, it should be consistent to all the routers. So auto cost correction, auto cost command should be applied to all the routers participating in the routing domain. Alright, so we've done all the requirements. Okay, and this one, configure the OSPF cost value to the HAU interface serial 0 is 1 to 60. Okay, so we need to configure this one in the HAU1. HAU1, this one. Config T router OSPF 10 interface serial 0/1/1 IPOSPF cost value is 60. Okay, so end. And then the last requirement is configure the hello and dead timer values on the interfaces that connect DCT and HAU1 to be twice the default value. So the default value is 10 times 2, that is 20, and then 20 times 4 becomes 80. So let us configure from DCT and HAU1. This one. Config T router OSPF 10 interface serial 0/1/0 so is interface serial 0/1/0 IPOSPF hello dash interval is 20, and then the dead interval will be 4 times, and then this will become 80. Okay, and okay, now here also S002 2 config t. So if you notice, it was down because they are not of the same hello and dead timer. Interface a router Ospf 10. Interface serial 0/2/0. IP Ospf hello dash interval 20, and then we need to change this one to dead timer. Okay, and right, so show IP Ospf interface serial 0/2/0. Time is 0, is not yet. Interval is 20 and 80 now. It should be the same here. Show IP Ospf interface S0/1/0. Okay, so they are the same now. So they are established communication, established neighbor adjacency. Okay, so let us put some design here. So this is the multi-access network, and then this is the point-to-point network under the single area network. Alright, so that is the solution for the practical exam. Alright, so if we're going to check, let's say I made a packet here. Okay, so they are connecting. If I using ping, if I'm going to ping the IP address of the server, ping 205.0.113.100. Okay, so that means there is a communication out to all the routers. So if I'm going to put a simple PDU here, and it was successful. Okay, so that means the Ospf routing domain is successfully configured, and they are now converged network. They're communicating to each network. Okay, so that will be the solution for the practical exam.